What if I told you that everything you've ever known, this planet, this universe, even you, might be just one tiny bubble in a vast cosmic ocean? It might sound like science fiction, but it's a theory taken seriously by some of the world's leading physicists. Scientists like Max Tegmark, Greene, and Andrei Linde have all explored the possibility that our universe is not alone. In this video, we'll explore why scientists think the multiverse might be real, based on real, peer-reviewed theories in physics, and not fantasy. Let's start at the tiniest scale, the quantum level. In quantum mechanics, particles don't have definite positions or states until they're observed. Instead, they exist in superposition, multiple possibilities at once. This leads to the famous Schrödinger's cat thought experiment, where a cat is both alive and dead until someone checks. To explain this, in 1957, physicist Hugh Everett proposed the many worlds interpretation. It says, every possible outcome of a quantum event actually happens in separate parallel universes. So every time you make a decision, the universe splits. In one universe, you clicked this video. In another, you didn't. This isn't just imagination, it's a serious interpretation of quantum physics. And quantum theory is one of the most well-tested models in science. Many physicists, including Max Tegmark and David Deutsch, argue that many worlds is the most straightforward reading of quantum mechanics. So if we take quantum physics seriously, we have to take this quantum multiverse seriously too. Now let's zoom way out, to the scale of the entire universe. Right after the Big Bang, the universe expanded incredibly fast in a process called inflation. This theory explains why the universe is so flat and uniform, and it's backed by real data from the cosmic microwave background. But here's the twist, many versions of inflation predict that it never completely stops. This leads to what's called eternal inflation. In this model, inflation stops in some regions, forming bubble universes, but continues in others. New universes keep forming. Forever. Our universe? Just one bubble, and there could be infinitely more. Andrei Linde and Alexander Vilenkin have shown how eternal inflation naturally creates a cosmic multiverse. Each bubble could have different physical constants, maybe different laws of physics altogether. Scientists have even searched the cosmic microwave background for signs of past collisions with other universes like circular bruises. So far, no definitive proof, but serious research is ongoing. Now let's ask, why does our universe have the laws it does? Why is gravity so weak? Why do particles have the masses they do? String theory, a leading candidate for a theory of everything, offers an answer. Instead of predicting one unique universe, string theory suggests a vast landscape, possibly 10 to the power of 500 different vacuum states, each corresponding to a different set of physical laws. That's not a bug, that's a feature. If true, then our universe is just one valley in this landscape. This ties into the Anthropic principle, the idea that we live in a universe with just the right conditions for life, because only such universes can support observers like us. Combine this with eternal inflation, and you get a multiverse where all possible universes are realized. This isn't hand-waving, it's based on work by scientists like Leonard Susskind, Raphael Bousso, and Joseph Polchinski. And remarkably, the tiny value of dark energy in our universe, once seen as unnatural, makes sense if you accept this multiverse idea. Now, it's true, we haven't observed another universe directly. Some critics argue, if it can't be tested, is it really science? But remember, these aren't made-up stories. They're predictions from theories we already have reason to trust. Quantum mechanics, inflation, and string theory are all active areas of research. And if those theories are right, a multiverse may be the logical conclusion. Scientists are even trying to test these ideas by looking for gravitational wave signatures or unusual patterns in the cosmic background. We're not there yet. But the search continues.